In this video, we're going to talk about the standard form of the quadratic. So we know that we've already talked about the general form, or what our book calls the general form of the quadratic function. That is ax squared plus bx plus c, where a is not equal to 0. It is also possible to rewrite the quadratic in what our book calls the standard form, which is a times x minus h quantity squared plus k. Again, a here has to be non-zero. I forgot to write that on here. So what is the benefit of the standard form? Why would you want to write it like this? Well, if you have a quadratic written in the standard form, then h comma k is the exact vertex of the parabola in there. So it makes it a little easier to pick off the vertex if it's written in this form. The downside is it kind of takes a little bit of work to write it in this format. There is a technique for writing a quadratic in the standard form from the general form using completing the square. I'm not going to talk about that because I've already showed you kind of the shortcut for it. And so what ends up happening is that most people will use the shortcut, which I showed you already. So I'm just going to go ahead and do that. I will say that if you are moving forward in math and taking more math, then you need to know how the completing the square technique works, because it is useful in other situations besides just solving quadratics. So if you're interested in that, just let me know and I'll be glad to make another video showing you exactly how to do that. Okay, so this is the standard form, and like I said, h and k, right, are the x and y coordinates of the vertex of the quadratic, and then this a here is the same a that's with x squared there, right? So that's important to know that as well. Okay. All right. So what we're going to do is work through some examples of writing, starting with the general form, writing a quadratic in the standard form. Okay. Okay, so the first one is f of x equals minus x squared minus 4x minus 3. We're going to write that in the standard form. In the process, we will find the vertex, and then we'll take a look at the graph of the quadratic in Desmos. Okay. So like I said, my first inclination here is just to go ahead and find the vertex. We've already seen how to do that, right? Make sure that it's written in the general form. Pick off what your a and your b is. A is -1, b is -4 in this example. And then use the minus b over 2a, right, to get the x coordinate of the vertex. So b is -4 and a is -1. So I will wind up with -4 over -2. And that will actually be a +2, but then this negative sign will change that back to a -2. And then I take this -2 and I plug it in for x into the original, right? And when we do that, we get this, again, kind of this tricky part here where I'm plugging in a negative number into x squared, and I also have this negative out in front. You have to be careful about that. Again, the solution to being careful of that is use the order of operations, right? The exponent comes first. So it's -2 squared. That would be -2 times -2, right? Which is +4. So -2 quantity squared would be +4, but then we still have this minus out in front. So that winds up or results in a -4. Here I just went ahead and multiplied -4 times -2. That gives me a +8, and then -3. That all works out to 8 minus 7, which is a +1. Okay. So that gives us the vertex being -2, right, for the x and +1 for the y. Okay, so now that we have the vertex, then we are going to substitute those into the general form, right? So h, right, is the x coordinate of the vertex. We would plug it, and we know that that is -2, right? Our vertex was -2, 1. So we take a -2, put it in for h. We'll get x minus a -2, right? Quantity squared. We'll plug that 1 in for k. The a, where does that come from? Well, in this problem, right, since they gave us the general form, we know that that is the number with x squared. And if we go back, we can see that the number with x squared was a -1. So we know right here, right, that a is equal to -1. So that number goes in for a right here. And then all we need to do is to simplify that. You will generally see if the inside is x minus a negative, they will rewrite that as x plus a number. Okay. And then also this -1 will generally be written as just minus out in front. And so that is a little bit tricky. Remember, the vertex was -2, 1. And because of that minus that's in the standard format, when you plug a negative in for h, when the vertex x coordinate is negative, it is going to change that to a plus. Remember, this kind of goes back to those transformations and replacing x by x plus a number or x minus a number, and how that kind of works backwards of how you think it should work. So anyway, this is the vertex, or the standard format here. All right, let's take a look at Desmos, and I think this example is here. So we started off with this parabola, right? We got the vertex was -2, 1, and this is our answer in the standard format. And I just graphed both of those so you can see it's giving us what looks to be exactly the same graph there. Okay. All right, next example. Write the quadratic function f in the standard form and find the vertex. And then we'll sketch the graph. Okay, so same approach here. We're just going to find the vertex because that's not super hard to do, right? And so pick off a is 7, b is -42, and then use the formula minus b over 2a. Okay, and when we do that, we'll get -42 over 14. -42 divided by 14 is -3, but then this minus, right, changes it to a +3. So the x coordinate of our vertex is +3. Then take this 3, right, and plug it in here for x, and we'll get this. So that would be 3 squared is 9, 9 times 7 is 63. 42, -42 times 3 is -126 plus 5. That comes out to be -58 when you plug the 3 in. And so the vertex is 3, -58. Okay, so 3, -58. Let's write that down here. Because what we're going to do is now go to the standard format. And then our a, right, was 7, remember from the original. That's the number with x squared. So, oops, I forgot it goes away on this. Right, so a is 7. Right, so we plug the 7 in for a. And then it was 3 and -58. So you can see how that's all we really did. Plug the 3 in here. Plug the -58 in for k, and then just wrote it as -58 instead of plus a -58. And that's it. There's really nothing to reduce here on this one. It's written in the standard form. All right. Next example. just the same problem with a different. Oops. Let's take a look at the graph before we do this one. So yeah, there we are. Okay, and so there's our general form version of the parabola, and here is our. When we graph it in the standard form, we can see it looks to be exactly the same as the original graph there. All right, next example, same approach. We're going to find the vertex. So our A is 2 and B is 24. And we use the minus B over 2A formula, right? So B is 24 and A is 2. So we get 24 over 4, which is 6. But then this minus changes to a negative 6. And then that's the x coordinate. Take that negative 6 and plug it in for x into the original and work that out. So here I have 2 times negative 6 quantity squared. Negative 6 times negative 6 is positive 36. And you can see that's going to be positive 72. Another typo there. So positive 72 minus 144 minus 138. And that should come out to be negative 110 on that one. Okay. So that makes our vertex negative 6, negative 110. All right. So now we are going to take that and put it in the standard form. Remember our A was 2. That's the number with x squared in the general format. And our vertex was negative 6, negative 110. Okay, and so we just plug the 2 in for A, the negative 6 in for H, and the negative 110 in for K. And about the only thing that we really probably should do here is rewrite that as inside as x plus 6. Just looks a lot simpler and cleaner, right, than x minus a negative 6 inside there. And so that's it. We have this one written in the standard form. All right, let's see. There, here we go. All right, so here's the original in red. See, there's the vertex, negative 6, negative 110. And then here is the green one, right, is the standard form version. You can see it's giving us the same graph there. Okay, so let's just bounce back to this one and make sure that... Okay. So now the next examples, the next 2 examples, are finding the equation from the graph, okay? And so you can see that they have the graph of a parabola. We can tell, you know, by the basic U shape. And they give us the vertex here. And they give us another point on the graph. And what they want us to do is to write the formula for the quadratic, or the function, okay, in the general form. All right, so the first thing that you need to do in this problem is to pick off what these points are. I should have marked these axes, but I didn't. So that's 1, 2, 3. All right, so the x coordinate of the vertex is 3. The y coordinate is 1, 2, 3, 4. So the vertex is at 3, 4. And this point is at 2, 1, right? The other point that they give us. All right, so we're going to need to note those, and I'm pretty sure I have those written on the next slide. Yeah, the vertex is 3, 4, and the other point is 2, 1. Okay, so what are we going to do with that information? So what we are going to do is start with the standard form. We know that in the standard form, H is the x coordinate of the vertex, so we know that that's a 3, and we know that the k is a 4, right? So first thing that we are going to do is just plug those straight in because we know exactly what those are. So that just leaves this a right here that we have to figure out. And how we're going to figure out what a is by using the other point. Okay, the other point, what we're going to do is take the 2 and plug it in for x into both these spots right here, because that is the x coordinate of the other point. Okay, so that's what we're going to do. All right, so you can see I took that 2 and I plugged it into this x and this x in here. And now I'm going to simplify this side as much as I can. So 2 minus 3 is -1. -1 squared is a +1. And +1 times a is just a, right? Okay, so that's about as simple as I can make this, right? Now then the question is, f of 2, what is that? Well, that is the number that you would get if you plug a 2 into whatever this function is. And we know that that is just going to be this y coordinate, right? When you plug an x value into a function, the number that you get out, f of 2, is the y coordinate, right? So this y coordinate now is going to get plugged in place of this f of 2. This whole f of 2 just gets replaced by whatever the y coordinate of the other point is, right? So in the next slide, you're going to see 1 equals a plus 4. All right, so there it is. And now that's just a simple little equation that we solve by subtracting 4 from both sides. We get a equals -3. Okay, so that means we know everything. So we know exactly what the standard form is. -3 times x minus 3 quantity squared plus 4. Okay. All right, that's great. We have the standard format, but if you recall, they asked for the general format, right? And so what we'll need to do to put this in the general format is just multiply all this stuff out, and that will be our answer, okay? So let's go ahead and go through that. All right, so first thing is, according to the order of operations, I need to do stuff in parentheses. There's nothing to do inside there. I do have some exponents, so those exponents need to get done first. Again, you need to be careful about how you do that. When you square something, right, it means take that thing and multiply it by itself. So if you do that, right, if you take the quantity x minus 3 and you multiply it by itself, then it's a lot easier for people to see, okay, we need to FOIL this out, right? And so then you would go ahead and FOIL that out. So that would be the next step. X times x is x squared. X times 3 is minus 3x. Minus 3x times x is minus 3x. -3 times -3 is +9. Okay. And now I have some stuff in parentheses that I can combine. I can combine these two. So I'll have a minus 6x in there. Okay, and now the inside of the parentheses, I can't do anything else. So the next thing is to distribute that -3 to each of these terms on inside the parentheses. So you'll see that in the next slide. So I had -3x squared times x squared, or -3 times x squared gives me -3x squared. -3 times -6 will give me +18x. -3 times 9 will give me -27. And then the last thing to do is just to combine the like terms in here. So this is the answer that they're looking for. Okay, so let's take a look at that on Desmos. I think it's here. Oh. Yeah, here it is. Yes, that's it. So 3, 4 was our vertex, and 2, 1 was our other point. This was the standard form, answer that we got. And then this is the answer when we multiplied it out. All right, one more like that. All right, same problem. Determine the equation of the parabola graph below. Write your answer in the general form. So first off, you want to pick off these 2 points. So this is going to be -1, -2. And then -1, -2, -3. So the vertex is -2, -3. The other point is going to be 0, right, on the x, and -2 on the y. Okay, so those are 2 points that we have to work with. -2, -3, and 0, -2. All right, so where do we go from there? We go straight to the standard form, because all we need to do is to plug h and k in. We know that h is the x coordinate of the vertex, so that goes right in there. The -3, the k is the y coordinate of the vertex, and we have that information. So that's just straight plug in that stuff. And I did go ahead and do this simplification here of the 2 minuses, and I made that a plus. Okay, so this is what we have to work with now. And again, really the only thing right now that we don't know is the value of a. So what do we do next? We use this other point, right, to find the value of a, right? So for 0, go away. The 0 goes right here in for x, and then we're going to simplify that down. Okay. All right, so 0 goes in there. And then 0 plus 2 is 2. 2 squared is 4. 4 times a is 4a. Okay, so this side is as simple as I can get it. And now the question is, okay, what's f of 0? But we know, right, f of 0 is the y coordinate right here. That is the number that you get. If you take this 0 and plug it into the function, it's going to get -2. We know that, right, because the graph, this point is on the graph of that. So we're going to take this -2 and replace this entire f of 0 by the number -2. So on the next slide, you will see -2 equals 4a minus 3. Okay. Okay, and now we would solve this linear equation, right, for a. So add 3 to both sides. I'll get -2 plus 3 is a positive 1, and then divide both sides by 4. You will get a equals 1/4. And so that gives us our standard form, right? We already had a times x plus 2 quantity squared minus 3. So now we know that the a is 1/4. Okay, so there's our answer in standard form, but, right, they want the general format. And so we're forced to multiply this out. And we really can't really do anything about that fraction. It just kind of has to stay in there. And we have to carry it through. There's no getting rid of it. We're not solving this equation, right? We're just putting it into another form. So, okay. So proceeding from there to put it in the general form, the first thing that we can do here is the exponent, right, according to the order of operations. So again, my advice is to rewrite that as to what it is always, so you don't make any mistakes there. And you write x plus 2 times x plus 2. And then actually multiply that out. X times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. And then next I'm going to combine these two like terms inside here to get a 4x. Oops, I hope that shows up on the next slide. It does not. So I put it, and it's like on this slide but too low to see, so I'm going to write it right here. So 1/4 x squared plus 4x plus 4. Okay, so that's what you'll will see when you combine these two things here. All right, so from there, what I would do is now distribute this 1/4 to each term inside the parentheses. And that might be what I have in the next slide. Yes, it is. So I'll have 1/4 times x squared, 1/4 times 4x, and this 1/4 times 4. So there we can pick it back up. All right, and here there's nothing really to do with that. That's about as simple as it can get. Here I have 1/4 times 4, and that just comes out to be a 1. And same thing right here. So that actually turns out to be not too bad. 1/4 times 4 is 1. This 1/4 times 4 is 1. And so that's kind of nice because now I don't have to get a common denominator to do this last bit, which is just to subtract 1 minus 3. So I'll get minus 2 in that case. All right, and so this is the answer that they're looking for in general form. Let's take a quick look at it. And it is not here, right here. All right, so there was our minus 2, minus 3. Our vertex, and our other point was 0, minus 2. This was our answer in standard form. And then when we multiplied it all out to get it into the general form, that's the answer that we had there. And you can see that that looks identical as far as we can tell on Desmos. Okay. All right, so that's it. So based on the videos, you should be able to do this characteristics of parabolas Newton assignment and the graphs of quadratic functions Newton assignment. It generally, you know, when we were doing face-to-face, I gave you a week, right, to get those problems done. So these problems that I'm going to assign you today, and there is one more after this one as well, those will be like due in 2 weeks. If you have any questions about the Georgia View due dates, those are all set in the course calendar, and of course you can contact me as well on there. Okay, so that's it for this video.